Hi everyone, so in this video we're going to talk about Kirchhoff rule. Okay, so Kirchhoff rule is a rule that is usually used for us to determine the voltage and the current for complicated circuits actually. Complicated circuits can mean by circuits where there are more than one battery, or the circuit arrangement is just so complex that it's not very suitable to do combined reverse that we discussed in the previous section. Okay, so Kirchhoff rule is based on a physicist named Gustav Kirchhoff. I think he's German, but I didn't learn any German, so I'm not sure how to pronounce his name, but never mind, let's just call it as Kirchhoff rule. I mean, if you know German, then probably you can pronounce it better than me. Okay, so Kirchhoff, there's two rules to it. So there's Kirchhoff first rule and Kirchhoff second rule. Kirchhoff first rule is also known as the junction rule, where it says that the algebraic sum of the current into any junction is 0. So because it's an algebraic sum, we should expect that there's a sum symbol over here. So there's a sigma. Okay, and it's a sum of current, and that it should be equal to 0 at any junction. Okay, because it says that into any junction, so sum is equals to sum of current is equals to 0 at any junction. Okay, so now let me explain this in further detail. So actually, to understand Kirchhoff first rule is not that difficult. Okay, I will probably relate it to something that you might be a bit more familiar with. Let's say today you have a river. Okay, let's say the river sort of flows something like this. Then it's sort of, there's a branch over here. So the river branch out into two sub-branches over here. Okay, so let's say I wish to study the current at 3 different points. So let's say there's this point I want to study the current, there's this point I want to study the current, and there's this point where I want to study the current. Okay, so let's say if I start with this point over here, when I study the current, it seems like there will be current flowing in this particular direction. Okay, I'm talking about water current. So this is river from a main branch splitting into sub branch. So let's say if I'm measuring the water current over here, I see that there's about let's say 10 liter. Okay, flowing through this checkpoint every second. Every second I see 10 liter of water passing through. Okay, then afterwards, if I choose to measure the water current over here at this cross section over here, maybe I will see something like 3 liter per second, maybe. So over here, because the water splitted into two branches, so maybe here you see a less water because it's a narrower branch. So you'll probably see 3 liter passing through this checkpoint per second. And by our logical understanding, it should be 7 liter per second passing through this sub branch instead. Okay. Why is it so? Because we assume that all the water that was previously flowing in this main branch will either be entering this first branch up here, or they'll be entering the second branch down here. All of the water will have to make a choice either to go to the upper branch or the lower branch down there. So that means if we sum up the water that passed through the first branch together with the water that passed through the second branch, we should get back the water that was initially coming into this junction over here. Okay, so that introduces to a very important concept. This point over here where it starts to split, we are going to call it as junction. Okay, so because we know that this is a junction, we can see that if there's current which is entering a junction, we can see the water is approaching the junction. This kind of current is flowing into the junction. So because this is what we want to sum up, therefore this one will be positive. Okay, so I will say that because this is into the junction, so therefore this one will be a positive sign. Okay. On the other hand, if you look at the current over here, we know that the current actually flow from the main branch, then enter the sub branch. So it should be leaving the junction whilst it flows into the sub branch. The water should be leaving the junction. when it flow out of this junction, entering this upper branch over here. So because it's flowing out over here, we should say that this is the opposite of what we are summing up. We want to sum up current into the junction, right? So out of the junction is opposite of what we want to sum up, so therefore the sign should be negative. So this should be out of the junction. So because it's out of the junction, we are going to assign negative sign to it. Okay, so the same can be said for this second branch over here. We know that our water from the main branch gets split into this sub branch over here. So if we measure the water and the water is coming in this direction, then we can see that it's actually leaving the junction, or it's coming out of the junction. That's why we can come up with a statement and saying that this is out of the junction, therefore the sign should also be negative, because it's opposite of what we want to sum up. We want to sum up current into the junction. So out of junction is the opposite of it, so we need to assign a negative sign to it. Okay, so based on this understanding over here, we can actually construct an equation to see that for this particular junction, there will be 10 liters of water coming in every second, but there will be 3 liters water coming out every second, followed by 7 liters water coming out per second. So you can see that if we sum them all up, it will all be equals to 0. So what does it mean? The amount of water flowing into the junction is equals to the amount of water flowing out of the junction at any point of time. So there is how much water coming in, there will be how much water coming out. So that's the idea that we're exploring when we're talking about Kirchhoff's rule actually. So that's why we can come to the conclusion and say that sum of I is equals to 0, where we can say that this is actually, we take current in to be positive, whereas we take current out to be negative. Okay, so now we understand this in terms of water current. Let's transfer our understanding into an actual circuit right now. Okay, in an actual circuit, okay, I'm just drafting over here. In an actual circuit, there will be similar things that we can call it as junction. Okay, so let's say if this is a very basic circuit over here, you might notice that there are points where there will be branching out, or there will be branches, sub-branches. Okay, so for example, if you look at region over here, you can see that if the current happens to go in this direction, let's say, you need to make a choice either to go into this branch or go into this branch, right? So this is a form of junction. Okay, another place where you can see a junction, it's here, where you might probably see that there will be current flowing, there will be current flowing here, and there will be current flowing here. Then they will combine, these two current will combine into a certain main branch, which is over here. Okay, so any point where you see there's current splitting into multiple branches, or you can see current combining to a main branch, this kind of situation, we call these points to be junction, just like the function of this particular point over here. Okay, like all students to be beware that these points over here, they are not junction. These points over here, they are not junction. Why are they not junction? Because there's no available options. Okay, there's only one path that you can flow. There's no alternative path for you to flow. There's no choice for you to go to another path. There's only one path to flow. So these green points over here are actually not a junction. Okay, so right now I'm going to sort of highlight this particular point over here. I'm going to highlight which point over here. Maybe I'll highlight something like this point over here. Okay, but I'm drawing base of the situation over here. So something like a junction over here. Okay, so let me remove this, because this is just to make sure all of you understand what's the idea of a junction. So if I want to represent this water situation in an electrical circuit, it will probably look something like this, where you have current, you have connecting wires. Actually, these are connecting wires, very poorly drawn, not straight at all. Yes, okay, so this is a portion of the electrical circuit that you see just now. If you look at a particular site, the particular junction, this will be how the junction looks like. Okay, so if you want to simulate this whole thing in a current situation, you can see that the junction, this point over here, should be this point over here. So let me label This is called a junction. Okay, so over here you can see that there's current flowing into the junction. So for this particular branch, you will see current flowing into the junction. Okay, so I'm talking about it in terms of electrical language. So right now this will be about 10 ampere or 10 coulomb of charge per second. Okay, reaching this junction, you see that this water gets split into two branches. So there will be upper branch and lower branch. So this is very similar to us having this junction to split the current 10 ampere here to 3 ampere and 7 ampere. So there will be 3 ampere leaving the junction, there will be 7 ampere leaving the junction. So we can probably label it something like this. So this is 3 ampere over here, and this is 7 ampere over here. Okay, so this is exactly the same thing, just that this is water current, this is electric current. Okay, so right now I can label those stuff that I mentioned just now. This is into the junction. So this is into the junction. I expect this should be a positive current in my summation. This is out of the junction. So because it's out of the junction, it's leaving the junction. That's why I expect to be opposite of the positive sign, which is a negative sign. And 7 ampere is also coming out of the junction or leaving the junction. So it should also be negative sign. Okay, so you also go through the same mathematical calculation where it's positive 10 minus 3 minus 7. If you look at this particular junction, that's why you can come to a conclusion that the sum of current into the junction is equal to 0. So into the junction, put it as positive, out of the junction, put it as negative. So if you sum them up, you should be able to get 0. So that's the idea of Kirchhoff's rule. It's just basic logical rule. Okay, so let's discuss a few logical branches that you might encounter or logical junction that you might encounter in your questions, and some illogical junctions that you might need to be aware of when you are solving a question. So here I'm going to talk about logical junction, and I'm going to talk about illogical junction. Okay, so let me draw maybe a few examples. So junction can exist on the left as well, no problem. Junction can exist at the bottom as well, no problem. Junction can exist on the right as well. Junction can exist at the top as well. Okay, so what are logical junction? Based on our understanding here, we know that any current, the amount of current flowing in should be equal to the amount of current flowing out, right? Because that's how much water coming in, there should be how much water coming out. So a logical junction over here, you should see some branches to have current flowing in, some branches to have current flowing out. So to give you an example, let's say if today we happen to see this is going into the junction, this is going into the junction. If two branches is already going into the junction, the third branch over here must be an out, because you cannot have all in. If you have in, you must have out. The amount of current flowing in must be equal to the amount of current flowing out. So you cannot have the third branch over here to be into the junction as well, because in that case there will be no current flowing out. So that's illogical. So you want it to be having in and out. Okay, another example is maybe let's say today you have current flowing out. You have current flowing out over here. So if there's two current flowing out already, you know that the third branch over here must be current flowing in, because you need to have something in, then only there is something out. So these two are logical options. While illogical, based on our understanding just now, we can have all current flowing in because there will be no current flowing out. We cannot have no current flowing out. We cannot have all current flowing out as well. So this is illogical, this is illogical as well. Because if you have a situation like this, there will be charges flowing into the junction, into the junction, into the junction. What happens is here there will be an accumulation of charges, which won't really happen if you have a complete circuit. Okay, over here is the opposite of things. You have charges flowing out, charges flowing out, charges flowing out. But where does charges come from? It sounds even more weird. It is as if there's a factory producing charges over here. So that is illogical as well. So you need to be able to detect whether the junction is logical or not, or if it's illogical, something is wrong. Okay, so make sure you are aware of this before you proceed to solve the question using junction rule or loop rule. Okay, so that's it for junction rule.